Okay, hi, I'm Philip Blackwell. Okay, so I'm going to talk about the chain rule. Okay, so the chain rule states that if f is differentiable at g of a and g is differentiable at a, then the prime of f composed of g of a is equal to f prime composed of g of a times g prime of a. Okay, and so using that, the chain rule, I'm gonna find the formula for the derivative, not the the derivative of an inverse. Okay, and so the derivative of an inverse is equal to 1 over the f prime of the inverse at x, right? Right. Okay, and so using that, I find the derivative of arctan of x is equal to 1 over f prime, and that's not the inverse, so this is f, and so this would be f prime. F prime composed of the inverse of f, which is arctan of x. And to get the derivative of this, it'd be arctan of x and you would substitute out secant squared for 1 plus tangent squared of arctan of x. That and that would cancel out, and so what you would get left is arctan, the derivative of arctan is equal to 1 plus just x squared, 1 over that, sorry. Okay, and so then, we follow the same logic from chain rule, the chain rule of two functions that are stacked. Then it would be the same for if we had f composed of g composed of h. If f is differentiable, if f is differentiable at g composed of h of a, and g is differentiable at h of a, and if h is differentiable at a, then the derivative of that would be f prime of g composed of a times the derivative of g of h of a times the derivative of h of a. And so, using this formula, I could find the derivative of three functions that are stacked onto each other. So, let's say the derivative of arctan of x of e to the tangent of x. The first function would be arctan of x, and then the next function would be e to the tangent of x, e to the x, sorry. And then the third function would be this tangent of x. And so, if the derivative of of f composed of g composed of h is equal to f prime of g composed of h times the derivative of g of h of a times the derivative of h prime of a, then the derivative of arctan of e to the tan x would be the derivative of arctan, which is 1 over 1 plus x squared, which is the x squared would be composed of the inside component, and so it'd be 10x squared times the derivative of e to the tangent of x, which is, the derivative of e to the tangent of x is just itself, times the derivative of tan of x, which is secant squared. And if we had a point that, let's say x, we could evaluate this, and so we would get, if we plugged all of it in, we would get 1 plus e to the tan of 0 squared times e to the tan of 0 times secant squared of 0. This would become 1 over 1 plus 1 times 1 times 1, and that would give me 1/2. And so the derivative of arctan of e to tan x at 0 is equal to